Hi, in this video we're going to talk about proportion and rates. So a rate is the ratio of two quantities. A unit rate is a rate with a denominator of 1. Okay, so they ask you, hey, your car can drive 300 miles on a tank of 15 gallon. Express this as a rate. So we can use 300 miles per 15 gallon. So since we are trying to find the unit rate, so by the definition, unit rate is when the denominator equals 1. So that means we need to divide it by 15 on the top and the bottom. So we will have 20 mile per 1 gallon. We can write it as 20 mile per gallon, or just okay. So proportion, the definition of proportion is an equation is showing the equivalence of two rates or ratio. So that means these two rates have the same ratio. So now take a look. We have 5/3 equals to 6 over x, and then we want to solve for x. So proportion means these two should be equal. So how do you solve it? You can times 3 on both sides, or times 3 on both sides doesn't work. What you can do is cross multiply. So you can use 5 times x is going to equal to 3 times 6. So I will have 5x equals to 18, and then I divide it by 5 on both sides. So I will have x equals to 18 over 5. So this is the proportion. Okay, so here's another example. A map scale indicates that 1.2 inches on the map corresponding with 3 real miles. How many miles apart are two cities that are 2 and 1/4 inches apart on the map? Again, on the map, they should have the same ratio. So we can set up the proportion by setting up these two equations. So the map scale inches over the real miles apart. Okay, that's the rate. That's the ratio that we have, and we know that this is equal. And then we also need to introduce the variable x to represent the unknown quantity. So we can say let x be the actual mileage between two cities. Okay, so by this ratio, we can say, hey, if on the map you have 1.5 inches, then in the real mileage is going to correspond with 3 miles. So they should be equal because for map, you should have the same scale, right? So for every 2 1/4 inches, we will have x mile. Okay, 2 1/4. Now, how do we calculate this? So you can cross multiply so that I have 1/2 x equals to 3 times 2 1/4. So in order for us to easily compute, we can convert it 2 1/4. 2 1/4 into a fraction, which is 9/4. Oops. Okay, so now we net 3 is equal to times 9 quarter. So I have what? X is equal to 27 over 4, 1/2 x. And now I times 2 on both sides to get rid of 1/2. So x is equal to, we simplify it, x is equal to 27 half, 27 over 2. Now we can convert this into 13 and 1/2 mile. So that means these two cities are 13.5 miles apart from each other. So many proportion problems can also be solved using dimensional analysis. The process of multiplying a quantity by raise to change the units. So now let's take a look at this one. Your car can drive 300 miles on a tank of 15 gallon. How far can it drive on 40 gallon? So now we know that we set up the proportion. So the proportion should be, you can either gallon over miles, because for the same car they should have the same mileage per gallon, or you can use mile per gallon, either way. So usually we use mile per gallon. So this is the proportion that we set up. So for my car, I know that my car can drive 300 miles per 15 gallon. So that's equivalent to what? 14 gallon and x mile. We can introduce the variable x as, let s be the mileage my car drives on 14 gallon. Okay, so now let's solve it. Again, cross multiply. I have 15 times x equals to 300 times 40. And then I divide it by 15 on both sides. So x is equals to 800 miles. So that's how you set up the proportion problem. So next one, a bicycle is traveling at 50 miles per hour. How many feet would the bicycle travel in 20 seconds? So first of all, here is different units. You can just set up the right proportion since they have the different unit. First of all, they ask you how many feet the bicycle could travel in second. But they give them what? The traveling speed is 50 miles per hour. First of all, we need to convert this 50 miles per hour into feet per second. So how are we going to do that? How can we convert this into feet per second? First of all, take a look. We know that the bicycle is traveling 50 miles per hour. So that means how many feet? So 1 mile, from what we learned last video, last week, 1 mile is equals to how many feet? 1 mile is going to equals to 5,218 feet. So that means 50 miles is going to equals to what? How many feet? 15 times the conversion ratio. 52 to 80. So now let me use a calculator. So I have what? 79,200 feet. So that means the bicycle's traveling speed, I can convert it as what? 79,200 feet per hour. That's my first conversion. So now the second one is I want to turn these into second. So 1 hour has how many seconds? 1 hour has 60 minutes, and then 1 minute has 60 seconds. So combine these two, we have 1 hour equals to 36,000 seconds. Okay, so now what do we do? Since this is divide, so that means to calculate that, we need to use 72 feet per hour times 1/36 second, because that's their conversion unit, right? So that when I simplify it, I have 22. So now the unit is done by conversion. So the traveling speed for that bicycle is 22 feet per second. Now I'm going to raise that. So after we're done with that, now we can use our proportion. So feet per second, that's our proportion. So when I'm traveling 20 feet per 1 second, it should equals to how many feet x feet travel in 20 seconds. Oh, 20 seconds, sorry. Now you can multiply them. Cross multiply, you will have x equals to 414 feet. So that means the bicycle is going to travel 414 feet in 20 seconds. Okay. Now the next one is, suppose that you're tiling the floor of a 10 feet by 10 feet room and you found that 100 tiles are needed. How many tiles are needed to tile the floor of 20 feet by 20 feet room? So in this case, why the width of the room is double, the area should be quadrupled, right? So the ratio shouldn't be the length over the tiles that needed. They should change to what? The area over the tile that you need. Okay, so the first thing we need to do is we find out the area. So you're tiling the floor at beginning, you're tiling 10 feet times 10 feet. So the area should be 10 times 10, which is 100 square feet. So that means every 100 square feet area, you're going to need 100 tiles. 100 pieces of tiles. Let's say pieces. The units would be the pieces. So this is going to equivalent to the new floor, which is 20 feet times 20 feet, which is 400 square feet. Again, area over the tiles. 400 square feet over how many pieces? We don't know. So this is going to be x. So now we can solve the x by cross multiplying. I have 100x equals to 400 times 100. And then you don't need to rush to use a calculator, because once you divide it by 100 on both sides, you will notice that, hey, the 100, they cancel out. So I have x equals to 1400 pieces of tiles. 1400 tiles needed. Okay, last example. So from the CIA website, we found the electricity consumption in 2011 for China is 4,693 kilowatt hour, or 4.693 trillion kilowatt per hour. While the consumption, not per hour, kilowatt hours, while the consumption for Japan is 859,700,000,000, or we can say 859.7 billion kilowatt hours. It's really hard for me to read this. The number is too big. So to find the rate per capita, which is per person, we also need the population, that two cities. So from the World Bank, we can find the population in China is 1.344 billion, and the population of Japan is 128.8 million. So compare the electricity consumption per capita in China to the rate in Japan. So for this question, you might notice that, hey, they have different units. How do we compare these two? So for China, let's just compare how many electricity per person use. So the total consumption is 4,693 million over the capital of China is 1,344,000,000 and 113,000 capita. So when you can use a calculator, you will get approximately, okay, this is kilowatt hours and this is per capita, per person. So you will get approximately 3,491.5 kilowatts hour per person. Whereas Japan, when we compare them, we have what? We write down the total consumption. No, that's the population of China, sorry. So the consumption, the electricity consumption in Japan is this number. I'm not going to read this again. And the population in Japan is 127,817,277. So by using a calculator, I will get 6,726 kilowatt hours per person. So now we can compare that, hey, which one consumed more electricity? So although overall China uses 5 times electricity of Japan overall, but because the population of Japan is so much smaller, it turns out Japan uses almost twice electricity per person compared to China. Okay, so that's it for this section. Let me know if you have other questions.